Hey guys, I am the math guy and today this is my first video. So today we are going to learn about conic sections. So this very diagram is known as a conic. So for you to visualize conic sections better, I want you to visualize this diagram with its center, which is this point, as the origin of the three-dimensional plane. If you are having any trouble, let me help you. Here we are. So I have drawn the three axes, but when we cut out the sections, these will actually look like two-dimensional figures. But even two-dimensional figures can be represented on three-dimensional planes. So yeah. Now if we cut a section in this manner, if we cut a section in this manner, say this is the plane. So this plane will cut this conic. This plane will surely cut this conic, and a section of this conic will be intersected by this plane. How will the section look like? The section will look like a circle when viewed from the top. So this is how the section will look like. From the top it will look like a circle. Very simple. Now there are various ways to cut this conic. If this plane does not cut it in the this plane is not parallel to the XZ plane. Say this plane is a little tilted to angle, say theta, so it will cut in this way. This plane is tilted at an angle to the XY plane, and this cuts this conic. This section is cut by this plane. That section looks like an ellipse when looked from the top. So this section is the ellipse. I will mark these. So 1, 2. This is 1. This is the ellipse. 2. Now there are two other conic sections, namely hyperbola and parabola. So if a plane cuts the conic this way, then the section which is cut by the plane when looked through this side, when we are looking from here, the section cut by this plane is an hyperbola. So this is how it looks. 3. This is plane number 3. The section cut is this one up here, there, and this one down here. And finally, if a plane cuts the conic in this manner, then the figure that we will get, the section that we will get, is a parabola. Visualize it from any side, you will see a parabola itself. So a parabola. Now let me highlight these on the conic itself, so it will make it easier for you to understand. Here we are. So the highlighted portions are the conic sections. This plane cut these sections into this conic. So after all this time, you might be thinking, what is a conic? So conic, it is the locus of a point which is moving in such a manner that the ratio of its distance from a point and from a line is same. So if this is a point and this is a fixed point, this is a fixed line, then the point moves in such a manner, this is the moving point. This is the fixed point. This is a fixed line. Line. So this is a fixed line. Now this point moves in such a manner that its distance from the point divided by its distance from the line, that is the ratio of its distance from the point to the distance from the line, is same at every point of the curve. This fixed point is known as the focus. This fixed line is known as the directrix. So we have found the definition of a conic. Now, what relevance does this ratio have? This ratio, distance from point by distance from line, this ratio is known as eccentricity, denoted by E. This E is very important. So now I will discuss the importance of eccentricity. Eccentricity varies for various conics. Say for a circle, eccentricity is equal to 0. For a parabola, eccentricity is equal to 1. For an ellipse, eccentricity is less than 1. For an hyperbola, eccentricity is greater than 1, and these are universal truths. They always happen. You can solve various problems just using the concept of eccentricity, that it has to be more than 1 or less than 1 or equal to 1, and the problem is solved. That's it. Now why these I will discuss when I am discussing circle, parabola, ellipse, hyperbola singularly. But for now, eccentricity is done, and this concludes my first lecture of conic sections. I hope you like it. If you did like it, please like the video and subscribe to my channel. And if you did not like it, I'm sorry. I will try better in the second video. Thank you.